All right, folks, we're going to start today off with a DESMOS activity. I'm not going to take you all the way through it, but I wanted to give you the opportunity to play around in there and see how if you could kind of use some of the things that we've been talking about. So again, you're going to go to student.desmos.com, and your class code for this one should be open for a few days is WJ7Q2B. All right, so press pause and get that opened up if you need to. Once you do, you should see uh, a whole user interface that looks like this, and you have 4 points here. They're obviously graphed over here as well, and we're going to move these points around because these points here are not the same as the ones that are there. So you'll notice that you can click and drag on each of these points and move them around. So the first one, let's grab here at the top, is going to be 1, 3. So 1 comma 3 is right there. 4 comma 3 right there. It's nice that they're all labeled. 4 comma negative 2 right here, and 1 comma negative 2. And so once you move those around, you should be able to see pretty clearly that that is definitely a rectangle, right? So um, type that in, see if you need it, but drag those points around to make sure you know what type of shape it is. And then once you know what type of shape it is, on the second slide, so I'm on slide 2, you're going to, we've already got our point set up, but the question is, well, what's the distance? If this is A, right here, 1, 3, what's the distance from A to B? Well, pretty self-explanatory, right? We've been practicing that for a little while now. You can just count that one through. And then are there any other vertices of the same distance apart? Well, yeah, definitely down here, C and D, right? So we've kind of been practicing these unique ones here for this type of idea for a little bit. So the distance is just going to be 3 units, right? 3 units. And B and C are also the same apart. So let's step it up a notch. Now I want you to graph um, the distance between B and C. Well, the distance between B and C, these two right here, we can simply count that as well because it's a vertical line. Or we can do the subtraction. 3 minus negative 2 gives me 5, right? So we can simply navigate that quite easily. Now we want to use it when it comes to area. So again, this is a practice of everything we've been working on yesterday and bringing it all together. So if we know that this was 3, right, and that the height was 5, we know that our area is just 3 times 5, so that's 15, right? Um, let's look at a new polygon. Let's look at a triangle. Again, we need to graph it. So negative 2, negative 3. I'm going to grab this one, drag it over to negative 2, down to negative 3, 0, 8. So I'm going to bring this all the way up here. And that one's already at 4, 0. So if we create our polygon here, make sure you do that first because the next screen is going to use this. So make sure your screen looks like mine. Once it does, we see that we have this triangle. And you may not realize it, but that's actually what we're going to do here is try to determine where is the base and where is the height of our triangle. So it's really important that we're able to determine where the base and the height of a triangle are. If we can't, it doesn't allow us to find the area, which is what's coming soon. Okay? So to find the base and the height of our triangle, what I want you to really make sure you identify is where is the right angle. The right angle is definitely right here. This is our right angle, okay, in that bottom left, bottom right hand corner there. So we can draw a little box if we want to. But by identifying the right angle, that helps us to identify the base and the height. Because the base of our triangle is simply one of the legs, so that could be this one. And then the height of our triangle is the other leg, this one. So basically what you need to know here is that the base and the height of a triangle will never be the hypotenuse, right? The hypotenuse would have been this long one right here. The base and the height, you could switch the purple and orange if you wanted to, but the base and the height um, are going to be our 2 legs. Now the question is, well, what are the measurements of those dimensions? So we need to use the Pythagorean theorem method here if we want to. So we can go ahead and find these dimensions. So let's go ahead and do this for the purple one. I'm going to go over, right? And then I'm going to go down here. So for the purple one, that's going to be over 1, 2, 3, 4. So I'm going to have the square root. Well, let's see if we click here. There we go. Square root of 4 squared plus squared plus the if we count down, that's going to be 1, 2, 3. That's just 8. I should just know that. Plus 8 squared, right? So that's our first component. That's going to be the height of my triangle, and then the width of my triangle is the same idea, right here. So if we count, we'll change it to orange. If we count down, that's going to be 3, right? That's going to be 3, and then over, that wasn't a very straight line, was it? Let's try that again. So straight down. Oh, I think they're just connecting on purpose there. And then across as well. So that's 3, and then across would be 1, 2, 3, 4, 5, 6, right? From 4 all the way over -2, 6. So we're going to, in this case, we actually need to create a fraction here. I'm wondering if I can do that still. Yes, good. So now I'm in the top. The fractions coming for a reason. We'll get to that in just a second. But now we need to multiply. So times, so base times height. So times another square root of 3 squared plus 6 squared. So all I've done here is this is my height with the square root, and this is my base with the height. So base times height, or height times base, however you want to slice it, and then you divide that entire thing by 2, because that's the formula for the area of a triangle. Well, I'm getting ahead of myself. All I needed to do here were the dimensions. So we can backtrack a little bit, but now we know. I'm just going to save that. Control A, Control C. And so our 2 dimensions, if we will, are simply that. We're going to have our 2 dimensions here. We don't actually need the fraction. All right, these are our 2 dimensions. So our first dimension, this is our height, and this is our base. Okay, and so now that we have those 2 dimensions, we can use that to find the area, right? We can use that to find the area. That's where I was getting ahead of myself there. And so, not what we wanted. Let's try this again. All right, there we go. So now the area of the triangles, when we multiply them and divide by 2, that's going to be the actual value for the area of our triangle. So sorry about that, but I hope that makes a bit more sense. Feel free to continue playing around with this. You can actually grab this and try to make it a parallelogram. So obviously don't cross over. That's not a parallelogram. But see if you can create a parallelogram by moving this point around, and then answer your questions from there. All right, in our next video, what I want to look at is just a little bit of practice for you and make sure that you're good to go.